We're gonna talk about our experiment. Our project is named Solar Hot Water Experiment. We want to make energy heated from the sun. And on this presentation, we're gonna explain you how does it work, how the solar energy works, and how we're gonna get it to work. As I told you, our experiment is going to be about solar heat. But where does the solar heat come from? As the name is told, from the sun. So what does the word sun means? Okay, the sun is a ball of fire in the sky that the earth goes around and gives us light and heat. As we all know, the sun is the one in charge of giving us light and heat. So we're gonna take the energy from the sun to give energy to a city, to a house, or someone else where it can be lighted up. The history of using the sun was first ever explained on 1861 when Muscat developed a steam engine powered entirely by the sun. So he was the first to make like a panel that was giving energy from the sun. And in 1883, American inventor Charles Fritz described the first solar cells made of selenium wafers. Here we can see like an invention of a little solar energy generator. This is an easy one that was made by an American gentleman named Kenneth West. He made this device with his own hand to make a cheap way of getting energy from the sun. Solar energy has many type of solar water heater. So I'm going to explain about like 4 or 5 types of energy of solar water heater. So the first type we have is the passive system. As we can see in the passive system, hot water is either stored in collector itself or it's transferred to a storage tank located above the collectors. It means that the water is stored by itself upstairs. As we see in the picture, there is a hot water tube and a cold water tube. We see that the hot water tube is connected by a side and the cold water tube is connected by the other. The sun is giving the heat to the collector panel, so both waters connects and that produces the energy. The second type we have is the thermospion system. This is a system that the sun shines on the collector, the water inside the collector flow tube is heated. So this means that there is like no cold water, but it's like the cold water is transferred into the hot water. So the water has to be heated and has to become hot water for the sun to make the energy work. So the third type is the integral collector storage system, also known as the ICS systems. This definition of the system says that the water is heated directly by the sun to the storage servers as a solar collector. So this means that the sun gives directly to the storage tank. So when the sun gives is where it's produced the energy. The fourth type is the direct active system, also known as direct open loop active system. This is similar to the thermocycline system in that they are direct system that is used solar collectors separate from the storage tanks. So as the thermocycline system says, and as is shown on the picture, both tanks of waters are separated, cold water and hot water. So when they mix up together and the sun gives the energy is where it's produced. Okay, so this last type is called an indirect active systems. So how does it is indirect? It is indirect because the external heat exchanger is used. So it's like all the opposite as we have been learning about. So these go from in to out. So that's why it's indirect system. There are two types of solar energy collectors. The first type is the solar energy and the second type is the flat plate. I'm going to explain you a little bit about the solar energy and the flat plate collectors. As you can see in the picture, there are the both types, the flat plate and the solar energy. As you can see, the solar energy is the one that is given by the sun. So the collector works in similar manner to the heat exchange. The solar collectors absorb radiation and converts it into heat, while the collector plate currently are manufactured into different forms. Firstly, collectors using liquid with no glassing and manufactured using a black absorbent polymer. So they are like related, but they are not because one work as way and the other ones work with another way. So here is just like more explained because here say that it's explaining about the evacuated tube collectors and the parabolic concentrators. So the evacuated tube collectors are efficiency for flat plate collectors, and parabolic are used for the solar collectors. As we know, there will be always things that affect other things. So in here, there are some factors that affect solar water heating. So I'm gonna explain it on the next slide. Okay, so here are the factors that I was talking about. The first one is the ambient conditions. This means that the temperature of the outside it's gonna influence a lot of the relation of the sun for giving the energy. The degrees on the sun of the weather it's gonna determine too if it can be possible or not. Another one, it could be the collector orientation and tilt. As I explained, there are type of collector. So it would influence which type of collector you would use according to the degrees outside the water. Here is just like the same about the collector arrangement. It will depend on which collector you will use to get the energy. And the other one it says that the transport fluid flow rate. So the collector flow rates of about 1 to 4 gallons per minute increase the thermal performance of the collector. So here, it's explaining about the application of solar energy. I will give you three steps to how apply solar energy at home or by using it anywhere you want. So the first step or the first advice is low temperatures applications. This means that it has to be below 100 degrees Celsius, such as solar dyeing, hot water supplies, or cooking. Number two, it be medium temperatures. It has to be below 150 degrees Celsius, such as refrigeration, industrial process, heat, and etc. You can have you can use these measured temperatures by those examples that I just gave you. And the last one, but not least, is high temperature. It has to be above 150 degrees Celsius. Applications such as electricity generator. So the most high is number 3. It has to be above 150 degrees Celsius. You have to be careful by using the third one, okay? So, as in every topic around the world, there will always be advantages and disadvantages. And solar energy is one of them. Some advantages of solar energy are: number 1, renewable energy source. Number 2, reduces electricity bills. It is less expensive than other types of energy. Number 3, diverse applications. Number 4, low maintenance costs. When you're gonna maintain this solar energy, you will not lose a lot of money because you're gonna make it with things that you have at home. And number 5 is technology development. Solar energy has become all over the world because companies are implementing this to make their price low, to make energy source more common around the world. So, here are the disadvantages of solar energy. Number 1 is the cost. It's like a little bit expensive. Number 2 is the weather dependent because if it's raining, you're not gonna have energy because you need the sun to keep going and flowing the energy. Number 3, solar energy storage is expensive. Number 4, uses a lot of space. You're gonna need like a more than a whole room or like a whole ceiling for making your solar energy. We can get 3 easy conclusions about the solar energy project we want to have. Number 1 is a renewable energy research. Solar energy is a renewable energy. Number 2, solar water heating. As I explained it, we have to use like thermal energy to make the solar energy work better with water. Number 3, however, there exist opportunities to further improve the system performance to increase its reliability and efficiently. We can keep improving and improving our project by making it better. So, as the last point of conclusions, I had to ask you a question. Are you ready to go solar? Don't forget that solar energy is a renewable source that doesn't make damage around the world. Thank you for your attention.